Hey, this is worksheet or practice 8.4b, working with some logarithms and in this case some inverses. Find the inverse of the following function. Remember, to do that we're going to switch the x and y. So to get this inverse, I'm going to switch the x and y. So x goes there, x equals log of 4 of y. Notice how I switched the x and the y. And so when we switch the x and the y, we want to then have y by itself. Well, if I switch this from log form to exponential form, that will happen. So remember, this is my base, this is my power, and this is what it equals. So base is 4, power is x, equals this thing. So 4x equals y, or y equals 4 to the x, 4 to the x equals y, y equals 4 to the x. Let's try this again. Let's switch the x and the y. Now from here, we are going to put it from log form into exponential form. So my base here is 10. Remember, if you don't see a base after the log, it's 10. So it's 10 to this power of x, equals this thing, equals 3y plus 2. Now we want to get y by itself, so we're going to subtract 2. So we get 10 to the x minus 2 equals 3y, and then we want to divide by 3. So y equals 10 to the power of x minus 2 all over 3. Bada bing, bada boom. Again, switch the x and the y, so x equals natural log of y minus 3. Now when we switch this from log form to exponential form, we want our, this natural log means our base is e. So it's e to the power of x equals y minus 3. Well, now we want to get y by itself, so we add 3, and we add 3. So y equals e to the x plus 3, or y equals e to the x plus 3 if you want y on the left side, which most teachers do. Same thing here. Let's switch the x and the y so we get it into exponential form. So x equals natural log of y minus 2. Now let's change it to exponential form. So our base is e when we have natural log. Our power is x, and it equals y minus 2. So to solve for y, we add 2 to each side. So y equals e to the power of x plus 2. There we are. Alrighty, so this is solved for y, but it's not the inverse yet, so we need to switch the x and the y again. So this already is in exponential form, but man, how do we solve for y? That's tough. Well, let's actually switch it to log form. So my base is 8, so it's log of base 8 of, so the power here is going to go to the equals sign or after the equals sign. And what the base to this power equals is x. That's our answer. So that goes actually right next to the base 8. So then from here, we just solve for y, so we'll add 4 to each side. So log base 8 of x plus 4 equals y. There we are. Oh, did you realize that I goofed up there? What I goofed up was just copying. This is plus 4, and for some reason I put a minus 4. So it should be plus 4 through there, and then when we solve, we'd actually take away 4. So that should be a minus 4, and that should be a minus 4. There we are. We should probably put this in parentheses just so we know that it's log base 8 of x, and then from that we're subtracting 4. All right, let's switch our x and y. So x equals e to the y minus 3. So now when we write down our base is e, so we're going to write the natural log ln. And then our power is y minus 3, but that goes over here, and whatever that equals actually goes next to the ln, or the natural log. So now we just need to solve for y, so we add 3. So natural log of x plus 3 equals y, or y equals natural log of x plus 3. Bada bing, bada boom. Let's do some converting. So with our change of base formula, we take log of the value of 7 divided by log of the base. I kind of think of this as like, all right, so this one's lower, so the 4 is lower, so it goes on the bottom. And the 5 is higher, so it goes on the top. 13's higher, so it goes on top. 6 is lower, so it goes on the bottom. I don't know, it's kind of just like my cheating way of remembering that rule. So then the cool thing about this, folks, is, you know, here we're really thinking, what does x equal? So really we're like 2 to the power of x equals 7. That's a nasty problem. Like, you'd be to guess and check, and it would get super tough to figure out what exact number. It's going to be a massive decimal. 2 to what power equals 7? That's crazy. Well, what's awesome is we can just calculate it. We can just do log 7 in our calculator divided by log 2, and you should get 2.80. I can't read my writing. I think that's a 1.4. Just a second. Sorry about that. Oh, yeah, it's a 7. 7.4. That's for this one. Here for number. All right, let's do some graphing. So, recall from the notes video that we are going to use the same numbers, -2, -1, 0, 1, and 2 most of the time, but those go in for the y's. Yeah, we reverse our inputs and outputs because it makes it easier to calculate. Another thing we do is, well, I'm getting ahead of myself. Let's look at the parent function. So the parent function is right there. Now I'm going to have to erase that in a little bit because once I evaluate this parent function at these values for y, I'm going to have to remember that I need to shift it left 2 because x is getting added 2 by 2. So I need to shift it left 2 and then down 1. So left 2, down 1. That's how I shift the parent or mother function to get the actual graph of this equation. So now when I calculate this, I'm going to actually convert this from log form to exponential form. So my base is 2, my power is y, and that equals x. And that's why we want to actually plug in these values for y, because y is like my input value, and x is going to be my output value. So here are my different inputs that I'm using. And so here I get 0.25 or 1/4. Here I get 0.5 or 1/2. Here I get 1, 2, 4. So let's put that in. 0.25, 0.5, 1, 2, 4. So in green, I'm going to have my parent function or mother function. Now when I graph this coordinate pair, careful, the x is 0.25. So I go to the right 0.25 or a quarter of the way, and then I go down 2. I go right 0.5 and then down 1. I go right 1 and then up or down 0. Go right 2, up 1, right 4, up 2. So I'm actually not going to make the curve because you guys have seen that when I curve it, it looks terrible. And really, that's not my end result function anyway. I want to take these green dots and move them left 2 to account for that shift, and then down 1. So each point, left 2, down 1. Left 2, down 1. Left 2, down. Try that again. Left 2, down 1. 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 Oh, so actually that red dot hits the other green dot. And so then, folks, I'm going to graph this. Now, it's never going to hit, when it starts to curve down really fast, it's never going to actually hit the value of -2, which it seems to be moving towards. And it will go up and to the right and down and to the left. But there is a vertical asymptote with these. It's never going to actually hit this line right here. It's never going to hit the line, or x will never equal -2. So that is our asymptote. It's the line that we're getting close to. It's like our limit, but we're not actually touching. So we're getting close to -2. That's our asymptote. Our domain is not all real numbers. X will never be less than or equal to -2. In other words, to phrase it positively, x has to be greater than -2. And our range is all real numbers, because this will go down forever and ever. Ranges are y's, and it will go up forever and ever. If you've never used Desmos to graph, you should do that. I don't know what I just did. So you're gonna, Desmos is the site that I was telling you about. So you can punch anything in and it will graph it. So I've graphed these two functions. The red line is what we're aspiring to graph. The blue one is the mother or parent function. And as you can see, that's never going to actually hit -2. And if you scroll down further and further, it would reaffirm that it never crosses that or even touches it. So that's that one. Whoa. Let's try the last one here. So again, start with your mother function, your parent function, and it's y equals the log 1/2 of x. And then I will perform a shift. I will just shift it down 3 from there. Let's convert this to exponential form. So my base is 1/2, my power is y, and that's going to equal x. So 1/2, remember our inputs are now our y's, and we'll use these for our inputs. So 1/2 to the -2, 1/2 to the -1, 1/2 to the 0, 1/2 to the 1, 1/2 to the 2. So this equals 4. Try it in your calculator. Make sure you put parentheses around this, folks, when you're using your calculator, or call it 0.5. This equals 2. This equals 1. This equals 1/2. Anything to the power of 1 is itself. Anything to the power of 0 is 1. Works for even fractions. This is 1/4. So let's see here. We had 4, 2, 1, 0.5, 0.25. So I'm going to just plot these points. I'm not going to even connect them. There we go. And this, if I did connect it, this would be an asymptote where x equals 0. It'll get close to the y-axis, but not actually touch it. But now let's shift it down 3. So shift every point just down 3. All right, so our graph will go up and to the left, but never touching where x equals 0. X will never actually hit 0. It's going to get close, not actually, and it will go down and to the right forever and ever. So we have a vertical asymptote. It's where x equals 0. It'll never touch that line. Our domain is all x's that are greater than 0, and our range is all real numbers. It will go up forever and ever, and it will go down forever and ever. And here is your Desmos picture of the function. The red one being our actual graph of this entire equation. The blue graph are those 5 points that I had in black right there.